Hello students, next we are going to discuss about the rolling on inclined plane. Consider one inclined plane. So this is the one inclined plane. It will be make an angle theta. Okay, inclined means it will be make an angle, some angle. So this angle is theta. Now consider one circular object. Okay, now consider as a one circular object. That object having radius r. Okay, so that object is placed in an inclined plane. Okay, without sliding. Okay, without sliding, that object is placed in a one inclined plane. According to free body diagram, what are the forces are acting? So what are the forces? Normally, so first actually that first gravitational force is acting. Downward gravitational force is acting. And what is that another one force? That another one force is a normal force. Okay. So there are two forces are acting. One is the normal force and a downward gravitational force. Then this downward gravitational force is an inclined plane only. Okay. So this will be resolved into two components. One is the horizontal component and another one is the vertical component. Okay, so this is the vertical component, that is mg sin theta, and another one force, that is mg cos theta. Okay, so there are two components. Mg is resolved into two components. One is the mg sin theta and another one is the mg cos theta. So it will be make an angle theta. Okay, it will be make an angle theta. Then next another one force is acting. What is that force? That is frictional force. Here that frictional force is acting F. So static friction, kinetic friction already we discussed now. Okay, so here that frictional force is acting. Okay, now according to free body diagram, so first that n and mg cos theta, n, so both are equal but opposite direction. So n minus mg cos theta is equal to 0. Why we put in 0? That object is not moving in a y direction. So you can consider this the x direction and this one y direction. Okay, that object is moving only in an x direction alone, not in the y direction. So that a is equal to 0. Okay, so here ma, n minus mg cos theta is equal to ma. Here there is no motion, so a value is equal to 0. So only I put a 0. N minus mg cos theta equal to 0. Then n equal to mg cos theta. So both are equal but opposite, so cancel each other. Okay, so n equal to mg cos theta. Then next another one case, mg sin theta. mg sin theta is equal mg sin theta. So here two forces, mg sin theta in positive x direction is acting and frictional force is acting in a negative x direction. So mg sin theta minus f is equal to, here that object, circular object is motion only. Okay, so it having acceleration. So you can put a ma. M is the mass of one that rolling object and a is the acceleration of that rolling object. Okay, so mg sin theta minus f is equal to ma. Here that object is not in a translational. Okay, so here rolling rotational motion is also happening. Okay, that suppose if the object is moving in a one square box is there, that object is moving sliding in this direction means only translation. But here that object is moving translational as well as rotational motion. Okay, translational as well as rotational motion. So this one. Okay, so here translational as well as rotational motion. So rotational motion, the torque only acting. Okay, so mg sin theta never act as a torque. Okay, mg sin theta is moving in x direction. Okay, that mg sin theta never acting in a torque, but that frictional force, F is the small f, that F is a frictional force. That frictional force can set up the torque. Okay, now we are going to find out the torque. Torque is equal to, what is the relation between torque and angular acceleration? What is the relation between torque and angular acceleration? Torque is equal to I alpha. Here torque is equal to I is the moment of inertia and alpha is the angular acceleration. So already we discussed the relation between torque and moment of inertia and acceleration is torque is equal to I alpha. Okay. Then here torque is equal to, in linear motion, torque is equal to, in rotational motion, torque is equal to I alpha. In linear motion, tau is equal to one of the force into perpendicular distance. That force, what is that force? That force is the frictional force. Okay, already I told now, frictional force is only set up in the torque. So torque is equal to Fr. You can substitute that. Fr is equal to I alpha. Here R is the radius of that rolling object. Fr is equal to I alpha. Okay, so Fr is equal to I alpha. Then here alpha is equal to, alpha is the angular acceleration. So the relation between angular acceleration and linear acceleration is A is equal to R alpha. The relation between angular acceleration and linear acceleration is A is equal to R alpha. Then from this equation, alpha is equal to A by R. Okay. Then next, what is the, you can put a name. This is the first equation and this one second equation and this one third equation. And next, what is the general moment expression for moment of inertia? What is the general expression for moment of inertia? I is equal to mk square. Okay, so I is equal to mk square. So this is the equation number 4. Now this third and fourth you can substitute in this second equation. Okay, substitute third, fourth in second. By Fr is equal to I. What is the formula? Mk square. So mk square. Then alpha value A by R. So A by R. Then Fr is equal to ma k squared by R. Okay. Then F is equal to ma k squared by R square. This R will be going downwards. Okay. So F is equal to denominator. So F is equal to ma k squared by R square. You can, so this is the equation number 5. Substitute 5 in 1. Okay. So F is equal to ma k squared by R square. You can substitute this value in first equation. Mg sin theta minus ma k squared by R square is equal to ma. Mg sin theta minus ma k squared by R square is equal to ma. Okay. So then next you can rearrange this equation. Mg sin theta is equal to ma plus, this will be going to plus. Okay. This side means plus ma k squared by R square. From this term, mg sin theta is equal to, from this term, what is that common? The ma is common. Okay, so ma of 1 plus k squared by equation, m both are cancelled. Okay, so we can get g sin theta is equal to a of 1 plus k square by r square. Okay, so from this equation you have to calculate that acceleration. So acceleration is equal to g sin theta equal to a of 1 plus k square by r square. Then a is equal to g sin theta by a is equal to g sin theta by 1 plus k square by r square. Okay, so this is the equation number 6. Then according to third equation of motion, now we are going to calculate that velocity. Okay, so velocity how to find out means we can using the third equation of motion. What is the third equation of motion? V squared is equal to u squared plus 2as. Okay, v squared is equal to u squared plus 2as. Here v is the final velocity and u is the initial velocity, a is the acceleration and s is the displacement. V is the final velocity. Okay, that final velocity we have to calculate. Then u is the initial velocity. When that object is rest, okay, initially that object is at rest, then it will be moving. So initial velocity u is equal to 0. Okay, then v squared is equal to 2as. We know that value of a is equal to g sin theta by 1 plus k square by r square. Okay, but s value we don't know. S is the displacement. Displacement means represented by the from this the point A and this the point B. Okay, so from A to B how much that rolling object is displaced. Okay, so that s value we have to find out. So s value how to find out. So this is the s and this is the height. From OA is considered as a height. Okay, how much height that object is moving. So sin theta you have to calculate. So sin theta is equal to opposite side by hypotenuse. Opposite side value h. Opposite side is equal to h by hypotenuse value, this is the s. Okay, h by s. Then s is equal to h by sin theta. Okay, s equal to h by sin theta. You can substitute this value to this equation. V squared is equal to 2as. Okay, so I can drop this. S equal to h by sin theta. So this is the equation number 7 and this is the equation number 8. Okay, so v squared is equal to 2as. A value v squared is equal to 2e. A value what is that? A value is equal to g sin theta by 1 plus k squared by r squared. Okay, but g sin theta divided by 1 plus k squared by r squared into s. S value what is that? S equal to h by sin theta into h by sin theta. Okay, so sin theta and sin theta cancel. So we can get v squared is equal to 2gh divided by 1 plus k squared by r square. Okay, then v is equal to square root of 2gh by 1 plus k squared by r square. Okay, v is equal to square root of 2gh by 1 plus k squared by r square. Okay, then v value we can calculate it, and A value also calculated. From this two value we can calculate the time. Okay, how to calculate the time? According to the first equation of motion. What is that first equation of motion? V is equal to u plus at. What is the initial velocity? V is the final velocity. U is the initial velocity, A is the acceleration, and T is the time. What is the initial velocity value? Initial velocity value 0. Then V is equal to at. Then T is equal to V by A. So V value we know that, and A value also we know that. Okay. So from this two value we can find out the time. Then time is equal to V value, what is that? Square root of 2gh divided by 1 plus k squared by r square divided by A value. A value, what is that? G sin theta divided by 1 plus k squared by r square. Okay. Then T is equal to square root of 2gh by 1 plus k squared by r square into 1 plus k squared by r square divided by g sin theta. Okay. So this value going to square root. Okay. So square root kulla you can giving that means you can now square, taking the square. So T equal to square root of 2gh by 1 plus k squared by r square into square root of 1 plus k squared by r square the whole square divided by g square sin square theta. Okay, that square and square root cancel, so there is no change in that value. Okay, so T equal to then square root of 2gh into 1 plus k squared by r squared the whole square divided by 1 plus k squared by r square into g square sin square theta. Okay, g and g square cancel, and this value the square cancel, and remaining T equal to square root of 2h 1 plus k squared by r square the whole divided by g square g. Okay, so remaining g sin square theta. But T equal to square root of 2h 1 plus k squared by r square divided by g sin square theta. So this equation gives the least value of radius of gyration. Those who are having least value of radius of gyration means k is the radius of gyration. Least value, it will become first. Okay, do you understand, ma? So this is the rolling on inclined plane. Okay, thank you.